In this video, we're going to talk about compound interest. Now, it's possible to develop the idea of compound interest without a formula, but let's go ahead and write the formula and then kind of talk about it. So if you wanted to calculate compound interest, the formula we will use, we'll call it A of t equals lowercase a times 1 plus r over k, all raised to the k times t. And each of these variables are defined below. A of t is the account value, t is measured in years, little a is the starting amount, r is the percent or rate, and k is the number of compoundings in 1 year. So briefly, compound interest is the idea that interest is being earned, but it's being earned often more than once a year. So like a credit card has compound interest every month. Every month you're going to be charged interest. So that kind of interest has an interesting kind of way of playing out. So let's see some examples of compound interest. First is a CD or certificate of deposit. It's a type of savings account. And basically you get a higher interest rate for a fixed length of time. So the idea is that you're basically loaning the bank money, and that's why they're paying you interest. And then they go out and loan your money to somebody else and charge them a higher interest rate. Okay, so they want to know, though, if you were to invest in this CD, what would be the or how much would your investment actually grow? So this is a perfect example of compound interest. Since it's monthly, that's how often your interest is going to be added to your account. So in this example, then, let me write the formula down. A of t equals a times 1 plus r over k to the kt. Okay, so real quick, in this problem, A is how much you're investing. So that would be $1,000. R is 1.2%, which I'm going to write as 0.012, change it to decimal form. Excuse me. And then K is the months, number of months, which is we're compounding monthly. I'm sorry, K is how many times how often we're compounding. So in this case, since it's monthly, K will be 12. And then T, you might remember in the formula is always in years. So 24 months would actually be 2 years. So I'll write that 2 years so that we understand why we did that. Okay, so let's use the formula to calculate this. So A of t, and you want to get your calculator too, equals 1,000 times 1 plus 0.012 divided by 12 to the 12 times 2. And I usually, when I do these, just simplify loosely inside the parentheses, just makes it a little bit easier to enter into the calculator, especially if you're not super calculator savvy. So I would probably start by dividing the 0.012 divided by 12, and that's going to end up with 0.011, which I would add to the 1. So inside the parentheses, I would have 1.001. And then outside the parentheses, as the exponent, I would actually go and multiply that. And that's what I would plug into the calculator. So I'm going to do that really quick. Raised to the 24 times 1,000. So I am getting $1,024. And I will go ahead and round the nearest cent since that makes sense. Wow, so much wordplay. Okay. So that's how much you would have at the end of 2 years. So you literally earn 25 bucks just letting the bank borrow your money for $1,000 for 2 years. And you earn $25 on that. All right. So let's try another one. Let's say you invest $3,000 into another account, but this one's compounded quarterly. How much will be in the account in 10 years? So let's try that. I'm not going to rewrite the formula since we have it written on the page. If you need to scroll up, there we go, just so we can see it. Okay, so this time $3,000 is our investment and the rate is 3%. So higher rate should end up being a little bit higher. Since it's quarterly, K is going to be 4 this time. So quarterly is 4 times a year. And then 4 times 10. Okay, So let's go ahead and plug this into the calculator. And actually, I think I have this one done. Let me see. Yep. So this one is 4,045.05. So that one earned over $1,000 in interest. Makes sense. You let it sit longer, higher interest rate. So the longer something sits, the more interest is earned, which is why a lot of people are always encouraging young people in their 20s and 30s to get retirement accounts set up immediately, because the more you can put into retirement, the more interest that gets earned, and it will just start compounding like crazy, sitting there in the account for so long. Okay, well, there are other ways to kind of work this out. So suppose you want to work backwards. In this case, they want to set up a college savings account for their granddaughter, and they're wanting the account to grow to $40,000 over 18 years. She found some account that will earn 6% compounded semi-annually. Semi-annually then would be twice a year. How much would Lily need to invest in the account now? Okay, so this time we're working backwards. 40,000 isn't what she's going to start with. 40,000 is what she wants to end up with. So they actually know the result, and they'd like to figure out how much they need to invest to make this happen. So we're going to solve this for A. Let's see, that's 0.06 is the interest rate. Semi-annually is twice a year, and this will be 18 years. Okay, so let's start by simplifying. This is going to be 40,000 equals A times 1.03 to the 36. And if you want to do it like with the least amount of rounding, you may want to go ahead and just divide right here. But there's nothing wrong with going ahead and plugging in the 1.03 raised to 36. Oops, I just realized I made an error. 1.03 raised to the 36. Okay, so I am getting 2.8983. As a general rule, especially if you are going to round, it's smart to go at least 4 or 5 decimal places out, especially if you're going to put it into MyOpenMath, because if you round it too close, your rounding might be off, and then it won't like your answer, because, you know, the computer's kind of dumb. It doesn't understand when you've rounded too much. Okay, so then dividing by that, 2.8983, I am getting 13,801 is how much she would need to invest in order to save up that $40,000. And remember, she's not investing every month. It's a one-time investment. She invests it, it sits for 18 years, and then there's $40,000 in there for her granddaughter after that period of time. Okay. Let's go ahead and look at this kind of discussion about compound interest, because it's going to lead into an idea that they do talk about. So based on if you are investing, like in this scenario, $1,000 at different types of compounding, one is annually, semi-annually, quarterly, monthly, and then daily. You can see the more often it's compounded, the more interest is earned. Now, it's not huge differences in numbers, at least not when you're talking about only a year, okay? But we are interested in comparing those differences. So if I was interested in computing the actual percent for daily compounding, all right? In other words, if I wanted to know how much the increase from the original $1,000 from that interest earned of $105.16, to actually calculate that interest, we would simply divide 105.16 by 1,000, and that's going to come out to 0.10516, or 10.516%. And this is referred to as the annual percentage yield, or APY. Now, there is a formula for just calculating the APY without first calculating how much interest is earned or how much is in the account and then doing this calculation. This is how you can calculate the APY. So let's look at an example of where this is used. Suppose Bank A offers an account paying 1.2% compounded quarterly, where Bank B offers a 1.1% account compounded monthly. The question is, which one is giving the better rate? And since one's quarterly and one's monthly, we know the monthly is more frequent, but it is a lower interest rate. And so we kind of wonder which one ends up being the bigger payout. Okay, so if we calculate the APY, the annual percent yield, that will tell us who's really going to end up paying out more in the end. So let's do this for both banks. So for Bank A, we will plug in, let's see, 1 plus 0.012. Since it's quarterly, that's divided by 4 to the 4 minus 1. All right, so here, let's just calculate that. That's going to be 0.01254, or as a percent, 1.2054%. Okay, so that's what I got. Now let's try Bank B. This time 0.011 and divided by 12. Oops. Raised to the 12th minus 1. Sorry, my 12 is looking kind of sad today. There we go. All right, and now I get for this one 0.011056, or 1.1056%. So the payout is technically bigger with the first bank. And the reason is its percentage earned for the interest that year is just a bigger percent. So that meant more money was paid out. So even though Bank B compounded monthly, that wasn't enough to catch up for that 1 year. All right. And in the next video, we'll talk about continuous growth and compounding continuously.